All right. Hello, everybody. Let's begin today's session. Welcome, and thanks for joining us. Hope you're each having a great day. My name is Colleen Berry. I'm the Marketing Director at Burwood Group, and I will be your host for today's session. Let's jump right into the topic. Our topic for the next hour is Where to Next? Advanced Application Modernization. Burwood is thrilled to partner with PrimeTSR for today's session. A little bit about our firm. Burwood is a IT consulting and integration firm headquartered in Chicago with offices and employees across the United States. We help our clients leverage the cloud to transform their IT infrastructure environments. And with PrimeTSR, an expert in digital transformation, cloud, and IT strategy, we've planned a very detailed educational session today, continuing on from our last session, talking all about how to modernize your applications. Going to the next slide, I'd like to remind everyone that today's webinar is the fourth and last of our four-part series on app modernization with Google Cloud. I know many of you have joined us for all four of these sessions. Thank you so much for sticking with us as we've been on this journey. If you have not been on, you can see the details of the last three sessions here, and you can catch all three of the first sessions recorded on Burwood Group's YouTube channel. Few housekeeping items before we begin. We've allocated an hour for today's session, and we are recording this. A recorded version of this webinar and the slides will be available following, and we'll send it out to all of you for your own continued learning. And if you have any questions throughout today, please use the chat or QA window on the right side of your WebEx window, and we'll get to as many as we can during and after. So if you have questions pertaining to what's on the screen, pop them in, and we'll try to answer real time if we can. So without further ado, let's go ahead and meet our presenters. I'd like to introduce Ed and Rich from the Burwood and PrimeTSR teams. They will introduce themselves and then dive right into the agenda. Gentlemen, please take it away.
Thanks, Colleen. Hey, everybody. I'm Ed Keene. I run the Cloud and DevOps group at Burwood, and looking forward to wrapping up rounding out this webinar.
And hey, everyone. Thank you again for joining. I'm Rich Gopikin. I'm a lead cloud solution architect at PrimeTSR. I also head our application development and GCP practices.
So we're going to kick off with a couple of polls. Rich and I are really interested to see what have you found most relevant so far in this wide area of modernization based on what we've covered so far. So we've got CI/CD, containerizing and moving to Kubernetes, moving to microservices, infrastructure as code, messaging bus, API services, or operations, not to leave operations behind. So really curious what's been most relevant so far. And then the next one. So now that you've gone through this and hopefully learned at least a little bit along the way, what are you planning on or where are you planning on going next on your journey? So do you plan on mapping out your current systems, so your current infrastructure and applications? Do you plan on building a modernization roadmap? Are you already getting started with modernizing your first apps? And hey, this is very much like a Google-focused series as well. You look at a start a pilot with Google Cloud too. So check all that apply here. We'll give everybody a minute to go through the they should pop up on your screen. While we do, Rich, do you want to tell us a little bit about your background?
Yeah, sure. So I've been doing this for about 15 years now. I started out as part of an IT organization, enterprise IT, moved to consulting about 10 years ago. I have a background in web application development, but I'm doing one of the architectures nowadays, however you define it. About 5 years ago, I joined PrimeTSR. Since then, I've just been extremely lucky to work on all sorts of different cloud projects between even AWS, Azure, and GCP. I've been both hands-on as well as doing just the hands-off architecture. So again, that's just kind of rolled the dice on projects, but I feel that I've been very lucky. Most of nowadays, I do enterprise architecture for some of our larger clients. And again, I head up our Google Cloud practice as well as our application development practice. So I just learn and learn and learn everything I can about the Google Cloud and speak it out as much as I can as well, which is what brings me here today. Ed?
Excellent. So I'm excited to join you from Chapel Hill, North Carolina, where if you've been paying attention to the webinar series, you'll see that I've had a different background behind me, probably during each of these webinars. This is my hopefully final landing place for an office. Doesn't look like much right now, but it will do soon. I have big aspirations for the walls in this office. So my background, I've been with Burwood for 3 years. I joined Burwood to help them evolve, how we evolve our cloud and DevOps practice. My background has all been at software companies, mainly focused on software delivery, so getting software from engineers' workstations integrated together and ultimately running in production. So being in software for probably 15 plus years too, doing this at different companies, picking up cloud along the way, where starting with AWS like most folks, and then building a fully automated Azure environment with everything as infrastructure as code, or CI/CD for getting an application into, and now on to really a very heavy Google focus recently, with the last couple of years while Google has invested in enterprise and bringing partners along the way. So that's my backstory too. Now we've given everybody a chance for the polls. Like Rich, the poll yet?
Yeah. I was just looking at them. Our first question about what everyone's gotten out of our series so far, and the highest percentage is Kubernetes, it looks like, in containerization, which I'm very happy to see. I think that was something we've just pounded on every single time, and absolutely something that I think everyone should take away from this. If you haven't, worked with them before, definitely start thinking about it, because hopefully out of this, you just realize the power that they have.
That's really interesting, because even a couple of years ago, I think when we would do webinars and workshops on Kubernetes, I felt like, okay, it's Kubernetes becoming old hat a couple of years ago. And so the fact that it's still top of people's mind and the top response here, somewhat surprising to me, but really, really great to see.
Yeah, absolutely. And the next one, where are you planning on going? So a lot of people, looks like they're going to start, actually the second question here, if I could ever drag it over. Oh, build their modernization roadmaps, which is perfect, because that's what we covered last time, and that's really what we're gonna, I think, dive deep into this time, about how to, which platform, you might want to start choosing with your modernization journey. Obviously, design and analysis is the first part. So hopefully, again, this helps you out.
Great, and I think the closely second was mapping out their current systems and environments as well. So obviously you need to know where you are before you kind of set off on your journey on where you want to get to. So that's great to see as well. So keep any questions coming, questions or comments as we go through this. But hey, let's get started with application modernization and moving into the advanced class. So recap quickly, in the last session, we talked about infrastructure as code, CI/CD, containerizing, Kubernetes, so getting these building blocks in place. Then we started digging a little bit deeper into, well, how do you actually start modernizing your applications now that you've got your building blocks in place? So we looked at how do you strangle your monolith and start moving out to microservices, start building new services like through APIs, implementing like a messaging bus and queuing system, and maybe like a pub sub. And then, hey, once it's up and running, like operationalizing it, making sure that operations is baked into everything that you're building. So that's what we covered last time around. In this session, we're going to go through platform modernization, more advanced capabilities within that Google provides for us as software engineers for where we want to build and run our applications on. Have a look at some serverless and functions as a service. Talk about ServiceMesh and more advanced modern networking capabilities as you start building more microservices. How do we make sure that we have the controls in place to manage this at scale? We'll look at test modernization, making sure that and quality is baked into everything that you're building, and so in like a modern, automated way. And then I'm going to geek out for a few minutes on AI ops and automation around operations as well. So this will be the 5 that we'll go through in this session. So kicking us off with platform modernization then, Rich.
Yep. So really quick, since we haven't called it out so far, if you see, we've had a Indiana Jones theme for this webinar. Our previous webinars, if you've been a part of them, we've always had a theme: superheroes, astronauts. I think the last one was Back to the Future, so usually movie-based. But hopefully this helps resonate as we're finding out how to, raid old, ancient crypts of code and bring them back out into the future. So high level here for modern application platforms. These are all of the pretty much application platforms that Google provides for hosting custom applications, as well as just application workloads like databases or other third-party apps and services that need to be provided. On the left side, you have more of your infrastructure on the service, and on the right side, it goes into more of the function as a service. And the goal at the end of the day is clearly, I think everyone wants to kind of get to that right side, but for at least custom applications. But it's a process getting there, and I want to dive into each one of these and say which one is right for you. If you want to go on to the next slide, Ed.
Exactly. I think as we start to move more workloads towards functions and serverless, what Rich is going to go into is it's not always a fit for all workloads as well. So how to pick the right tool for the job. Make your choice, right?
Yep. So I'd recommend not just picking one of these from random or what your favorite one is and just diving into that. You should start with a little bit more background knowledge about, as Ed said, what is good for you, because each one of these is a right choice, even for the most up-to-date programs. Even for the most up-to-date programs and applications, there's still reasons you might want to even run on Compute Engine or certainly Kubernetes and containers, as we were talking about running there. So hopefully we could guide you into making a correct choice. You want to go to the next one, Ed? So, the first thing you're going to need to do is start analyzing your workloads, and there's a lot of different ways to do that. You could look at what functionality your applications are providing. There's the resource limitations, which we usually refer to as our non-functionals, whether it's CPU intensive or GPU intensive, if you're IO bound or memory bound. You want to know also your frequency, about if you're getting spikes during certain times of the year, whether or not those spikes are predictable. Or whether or not you're just, static throughout. And then, of course, the technology, if you're building a custom application or even running, executables that are designed for certain OSs, you want to have a good feel of all this before you start going into making your selection. So don't be scared by this slide. I challenged myself to see if I could create the noisiest possible slide I've ever done, and I think I may have accomplished it here. I'm going to dive into each one of these individually, so you don't have to look at it like this, and hopefully at the end it makes more sense. But the main point I want to get out of this slide is that you're using containers whether you like it or not. Even when you use Cloud Functions and the App Engine or Cloud Run, your containers are happening behind the scenes. They've abstracted away a lot of it for you, but essentially that's the technology most of the cloud is built on, is using Kubernetes and containers behind the scenes for a lot of the services. And if you're not familiar with it, just to recap really quick, in the upper right-hand corner, how these containers work is you create a template file that basically is your basic definition. And, usually it's done using Docker, and a process builds that file and you get an instance of a specific container. And then after that, you take that instance and you deploy it onto a VM that's running the Docker runtime. And did I hopefully high level covered everything there? Anything I missed out in terms of the Docker build process?
No. I mean, that kind of nailed it, Rich. And then, so the key thing here, and the reason why we spent so much time in the last session on going through and how to containerize your applications is like that's your foundation and your building block. But what we're looking at here with App Engine, Cloud Run, in Kubernetes are just the different places to operationalize and run your container-based workloads and container-based applications.
Yeah. All of them, are either taking and building the containers for you, or deploying the containers for you, or both, and providing a suite of services around there. So the first two that I wanted to dive into is obviously you have Compute Engine, which is a basic VM. If you're really boring, and you want to just lift and shift to the cloud, sure. You do get a lot of that cloud power and redundancy about scalability, vertical with the VM. You get a lot of DR and HA capabilities. So again, there is some value to just doing a vanilla lift and shift, although we always push our customers to re-platform or at least go to Kubernetes, because that's when you really start to get the power. So quickly, to just compare, to go into the Compute Engine, you're basically getting one container image, and it's going to just replicate that across as many VMs as you choose. And you could create a managed instance group, and based on certain metrics and statistics, you could have automatic scale up and scale down. So you can scale both vertically and horizontally using the managed instance group. But your load balancer and a lot of those other functions are kind of like, you have to configure those themselves. They're not part of Compute Engine. On the Kubernetes side, this is by far the most way that you can get the most out of your resources. And it's the most flexible way to deploy all your workloads and all your applications. The idea here is that you could keep adding VMs to it. It doesn't matter if you have on-prem VMs or if you have VMs in multiple clouds. You just keep adding on VMs every time you need more power. But Kubernetes does a great way of abstracting what is actually running on which VM. It doesn't really matter. It has a lot of great logic behind the scenes to make sure your loads are balanced, and it does auto scaling for you. So when it sees that at least if you're running in the cloud, that's the advantage of the cloud, is if your the Kubernetes engine, or the Google Kubernetes engine, sees that your resources are really reaching their limits, you could set auto scaling rules to just add another VM, and I'll start dumping more containers on there. And the point of this is that you could create multiple containers and give it a definition of those. And the Kubernetes object config, that is how these containers interact with each other and how they interact with the outside world. Your VMs, usually you give them a single configuration of CPU, mem, and disk, and they just replicating based on that. But again, you could also plug in your on-prem VMs. You could plug in other cloud VMs. It's really a powerful technology, and it makes sure that the goal of it is to make sure you're using every last bit of power of those VMs before you spin up the next one. And you don't have to dedicate that this VM is for this container and this workload. It shifts them all around constantly behind the scenes to let you, to get the most out of them again. So these green dots represent maybe something that needed to scale up. If you had a first container, and let's say that was a microservice that was maybe it was generating an Excel document for your application front end. It was pulling stuff out of a database, generating an Excel document for your users. Let's say that microservice just got a little bit overloaded. It basically spins up another instance of that whole container for you and lets it start servicing more requests, and it handles, again, scaling all that in general. I know I've gone on a little bit about this, and Ed, you're probably a little bit more of the Kubernetes expert than me, so I definitely want to give you a chance to chime in here.
No, I think you covered that in good depth as well. And one of the only other thing I was going to mention in here is we covered in the last session, like the value of so the fact that Kubernetes will manage your workloads, right? Manage your container-based workloads across the VMs, auto scale your infrastructure as necessary. So it's great for managing your workloads. And then as far as managing Kubernetes itself, that's where like using a managed service like Google's Kubernetes engine or GKE is key. And we talked about this in the last session about like the do-it-yourself versus having Google or one of the cloud providers run it for you.
Yep, great. Yep, we go on the next slide. So here's where we really get into targeted platforms for custom application development. Again, these can be used for other workloads, but again, you're starting to target here. And the highlight to point out here is that you can use default containers that are out of the box, and you really don't even know you're running a container at the end of the day. If you talk about the Flex engine, if you have a program written in a very old language of Java, chances are they have a default image that you could just load up. It has Java on there already. It takes care of taking your code and putting it into the container and deploying out that container. And what they introduce all going forward is this concept of services, is that basically each container is at least for the Flex environment, gets its own VM and scales individually. So if a service is getting overloaded, again, based on your scaling rules, it'll just spin you up another VM with the power that you've specified, put that container in there and start running it. And it comes with a lot of great services out of the box that are part actually of the App Engine Flex environment. That's the load balancing and auto scaling and a lot of other app services like routing to your specific services. It handles all that, URL configuration, the HTTPS stuff. There's a lot that it's able to do. And again, it scales horizontally by putting those out, but you're limited. You basically one service and one image per service, and that's the way they run it. On the Cloud Run side, it's very, very similar to what the Flex environment does, but the one key difference is that you could go down to 0 instances. On the App Engine side, they call it services, and behind the scenes, it's VMs. They're really instances too. But on the Cloud Run side, they refer to them as instances. Again, you could go down, if your services aren't being used, they could go down to nothing, and they're completely stateless. And you can't attach a disk because of that. You might be able to work around it in a fancy way. Sure, you could start sending Zeta to a disk, but you would use the Flex engine if you needed that case. But the idea is, again, you're going more and more serverless. I'd say Cloud Run is really the delineation of where I'd start to say that you have a truly serverless framework where you have nothing, a request comes in, and boom, it starts spinning these up based on what request to what service. Anything else there, Ed?
Yeah, I think a key line here that we could almost draw between, as we go from VM to Kubernetes to App Engine Flex, would be state. Hey, is your application managed state? Do you need to be able to manage state, or are we starting to move into stateless? And then that's where we start to get into Cloud Run, and then obviously then into like App Engines, like standard and cloud functions, right?
Yep. And the nice thing about the other two, actually, if you want to go back just really quick for 1 second, Ed, if you go back one slide, you'll notice up at the top of the images that you're able to choose default images out of the box, which help you, but you're also able to provide your own images. And you were able to do this for both the VM, you're able to do this for the Kubernetes, as well as these two. So no matter what workload you have, even if you're running some application from the mid-90s, you're probably still going to be able to get it to run using these containers because it's abstracting the OS for you, and it's designed to run almost anything. Which, in one of our previous series, you went through the process of how to containerize. If you have an old VM server that's like Windows 2002, and God knows you have a couple databases on it, you have a couple other utility applications, maybe you have a few different versions of web servers, IIS, you can take that and go through a very relatively quick process of just making it into a container, putting a wrapper around it, and boom, you could put it into Flex environment, Cloud Run, or Kubernetes, right, Ed?
Right. There's tools like Chef's Habitat that will provide like a management layer for you, like in a control layer, so that you can containerize some of these like legacy Windows apps like that. Yep.
Yep. So yeah, sorry, we go to the next one now. I wanted to highlight that because that's the main difference between this and the next slide, which is in the App Engine standard environment and with Cloud Functions, you have a only out of the box and default images that Google provides. Now, they force you into this window, but what you have, the better thing about that is that they're able to spin up and down quicker. So I believe the Flex environment spins up the services and VMs in about 90 seconds, I want to say. Last time I checked, maybe a little bit more than that. But the App Engine standard environment, you're talking maybe 10 seconds, maybe even less than that. They continually improve those, so it's hard getting up. When you're talking about Cloud Functions, those come up in a matter of microseconds. They're really designed to be your backend services, potentially for a web application, most likely for, a web-based application that's hosting a spa somewhere and sending in requests to your functions.
We use Cloud Functions pretty heavily on the data side for performing like ad hoc data operations, and then also for on the operations side too, for like automating operations tasks. Like Cloud Functions would be great for that. And then it's
a lot of CI/CD stuff, right?
Exactly. Yep. Start managing them with PubSub as well, and you've got almost like a complete solution.
Yep. For sure. And that's actually absolutely the end goal. You go PubSub, you go to ServiceMesh to measure everything that's happening. You have a full application there. What the standard engine, I'd say, provides, or we could still go back. I'll go really quick, I promise. I have to keep my eye on this. The standard environment, it still gives you this sense of an application platform. It gives you this load balancing out of the box. It gives you these app services and auto scaling. It gives you a lot of nice things. When you talk about functions, you could still build an application platform out of it, but you're a little bit more on your own because these functions are diverse and they could use whatever. When you're selecting your size of your function, the CPU and MEM are attached. When you're in the standard environment, you could select this much CPU and this much MEM. Again, your choices are more limited, but you get, that quicker performance and, just more elasticity. Yep. So hopefully now if we go on to the next one, that this slide makes a little bit more sense. I know it might have been overwhelming to begin with, but again, you really get the feel. I almost drew this out for myself so I could keep in mind and understand what's going on here. There's the default images on the right-hand side. You have custom images on the left-hand side. Kubernetes, you're going to take care of all your loads. Ed, I'm going to let you talk through the rest of this, or go from here if you want to.
I love how you've done this, Rich, with being able to differentiate between like, hey, what's where's the container running? What is it running on a VM? Are they sharing VMs, or are they dedicated VMs? Where is it abstracted out entirely? Like in the case of like Cloud Functions and Cloud Run, and just running as instances there. It's like this is a super helpful diagram for me. I'm glad that I have a copy of it now too, Rich.
Perfect. I know that's one great thing about these presentations is I think a lot of the content we create is going to come in handy down the road.
Right.
Yeah. We go to the next one. So hopefully after you go through all this and analyze your workload and understand what the pros and cons are of each platform, you can choose wisely. Because I think in here we all know what happened to the guy who didn't choose wisely. If that's on the next slide, maybe.
It's not. So,
that's fine.
Well,
actually,
that is probably really good.
We wanted to keep this PG-13, and that might have been a little scary. So, but if you've seen the movie, you know what happens.
It's funny because maybe because in now talking about Microsoft and Windows, that might be the guy who didn't choose so wisely. So you might be wondering, oh, this is great, right? Like, okay, cool. For all of my Linux-based applications, excellent. I can start easily containerizing and then running them on any one of these 6 or 7 platforms. But what about my Windows apps? So our recommendation here, so I mentioned, hey, you can do, well, Rich said you can do a lift and shift into VMs, great. You're going to get some automation capabilities there, obviously, from the cloud providers. But you'll be a lot more limited in some of the benefits, the cloud native benefits that we've been talking about through the series if you do a lift and shift. Second option would be to look at a tool like Chef's Habitat, where, hey, it can provide a management layer and containerize some of your legacy Windows applications to help you be able to manage them a little bit more easily at scale on the cloud as well. And then the third and our recommended approach here is to modernize your applications, like by getting your hands dirty, going through what we talked about in the last session. So we'll start with strangling our monolith. So let's assume that our framework here is our monolith. Microsoft did everybody a big one by releasing like .NET Core and providing us as .NET developers a route and a path to be able to move to more cloud native. So we can start writing new services in .NET Core. We can start moving out some of our features and services from .NET Framework, start strangling that monolith and moving them over to Core as well. So that's what we're going with here, is like minimizing or shrinking down our monolith by strangling it, moving capabilities out into Core as well. So that's the first step for your Windows apps. The next one would be, now that you're running them now that you're building them in .NET Core, you can start running them on Linux. And now that you're starting to run them on Linux, hey, there's a whole world of capabilities for us in the way of containers and starting to build them into containers. So there's no reason not to just jump straight from .NET Core into running Linux-based workloads on containers. And now that you've containerized them, we can start running them on GKE, start running them on App Engine, and App Engine Flex, I think, is probably today about as far as we can get in on that spectrum, as far right as we can get. I don't think the Cloud Functions or Standard yet support .NET Core, but that's a heck of a leap forward to now being able to run our .NET applications on Kubernetes.
Absolutely.
So a little bit more about serverless and functions then, Rich, if you want.
Yeah, sure. So just wanted to get a little bit closer of a look into, all the things functions could do and what they can't do as well. So again, you'll never know what you're running on behind the scenes there in terms of where it is, but you can select your CPU power and your memory power that you'll get. But you will have a timeout. I think the last time I checked, it was around 10 minutes, maybe 9 minutes. Yep. And I think it's a minimum, they'll bill you per second as well. And again, common use cases, like you said, is automating tasks, real-time data transformation. You get that incredible horizontal scaling. That's the real power of these, is that you can have 100 different ones going in parallel for 100 different requests. And I've definitely wrote a few applications like this doing ETL, and they're great. It's exciting and fun to work on.
Yeah, and I think there's a ton that you can do with Cloud Functions. That, like Rich said, when you consider where to run your workloads, if you have longer running processes, right, like Cloud Functions might not be the right tool for you, or you'll either want to run those on Kubernetes, or you'll want to kind of parallelize them. And that's really where the main benefit of Cloud Functions that Rich mentioned, is the ability to infinitely scale horizontally. So if you can parallelize those workloads and processes and split them up, then Cloud Functions is a great fit.
Another thing that comes to mind with that is when we're talking about like PubSub and queues. You set up a pattern where that Google Cloud PubSub essentially is able to ingest everything. It's backed by Google Cloud Storage, actually. So think of it as just you're uploading things. It's designed to be able to consume as much data as possible, but you might not have the ability to process it as soon as possible. So that's where, you create a cloud function to keep pulling essentially from your queue. And again, a cloud function could be spun up for every single, request that comes in. You may want to limit how much it could be parallel. I think Google actually will start capping you at some point. It's not going to let you spin up 2 million cloud functions. But at the same time, even with your other workloads as well, the idea is you get that nice, buffer in between. And, no matter what goes on in back of your system, no matter how it goes down, you have all those requests saved.
Yeah, actually, there's a good point or two on the scale. Like we've hit like API rates, like limits before we've hit the cloud function limits. So like wherever we're pulling from, those APIs are the things that are kind of throttling us back.
Absolutely.
What we've got here is just like a pretty simple like cloud function that we use for a reporting basis, where hey, we have a cloud scheduler job, it's calling a cloud function that's going off, talking to BigQuery, generating a CSV from BigQuery, then saving that CSV to cloud storage, and then sending the link into Slack. So this is why I kind of called this out as a great tool for being able to automate tasks like this one, like building a report. So moving on to now, we've got microservices, and we've started modernizing our applications. We're starting to build more microservices. We got a good idea as to when we would run on Cloud Run versus GKE. Now, how do we start to manage these at scale? And that's where ServiceMesh comes into play. ServiceMesh is really interesting because it's really like a next phase of networking. So if you look at like traditional networking for data centers, you're often dealing with like pretty static workloads, like monolithic applications that have these like static IPs or long-lived IPs with pretty well-defined like north-south traffic paths. And you're often dealing with like perimeter security, perimeter network security. And the funny thing is like in the data center and even in like the early days of the cloud, same thing very much still applies. Like if you're doing a lift and shift, and especially maybe 5-8 years ago, and you're starting to build cloud environments, you're doing it as you've always known, with using like long-lived static IPs and perimeter security. As we evolve into one of the next phases of networking, this is where like ServiceMesh starts to look at more application-based networking. So we're using this to base our networking based on logical services. So this way we can then automate how the networks are built and managed and secured. Services can be discovered and connected automatically. And so now what we're really looking at is like having a modular approach with to managing our networks. And so this is where, as you build more and more microservices, you're going to start hitting a management threshold of how many load balancers can you build and manage, and finding a different approach. And I'll talk a little bit more about that in a minute through ServiceMesh. So at a high level, like a ServiceMesh provides probably, like in my mind, I kind of wrap it up into like 4 main benefits. So the first would be connecting. So dynamic discovery and connection of all of your services, whether you're dealing with dozens or thousands. So being able to do so at scale. Baking in security into those connections as well. So starting to move into internal zero trust security rather than just perimeter edge security. And so one of the benefits that ServiceMesh provides, and we'll talk about, is like enforcing mutual TLS and all service communication. Having control over that service communication. And I'll talk more about that in a couple of minutes on the next slide, as to what you can do with that control. And then because you've now got the control and you know what's talking to where and what's inside your network, you now have full observability as well. So you can easily identify bottlenecks, performance degradation, application issues, like through the ServiceMesh. At the highest level that I could just kind of whiteboard out, your ServiceMesh is looks like this. So we've got our microservice A, microservice B, alongside each microservice, we're going to run a sidecar. And we'll look in a minute at that acts as a proxy for that microservice. And then that sidecar or proxy is managed by your ServiceMesh control plane. And so this is, they get a lot more complicated than this, and we'll talk more about that in a few minutes. This is the highest level that I could think of a method of like kind of walking through what they look like.
Are those pods that are those essentially containers or wrap? Is that the same container as the same pods that are used in containers as well?
Exactly, yes. So this is looking at like a containerized microservice running, say, typically often like on Kubernetes. Like that's a great starting point for microservices. Cool.
Great. Yeah.
So in more detail here, this is looking at a more real-world implementation of ServiceMesh. So what we've got here is like a real-world 3-tier application, front-end, back-end database. So our ingress gateway, the traffic coming in is going through our sidecar proxy. In this case, like we're saying through our ServiceMesh and our control plane and our proxies, the front-end can only talk to the back-end. And then the back-end, and that traffic is secured. And then the back-end can only talk to the database. So the front end can't talk to the database. This is all managed by the ServiceMesh. So this is where that control comes into play. Control and then the observability as well. And then through our egress gateway and our proxy, only the back end can talk out outside, so through the egress. So I really like this for being able to see the north-south traffic and the east-west traffic, and looking at it from like a real-world application as well. They can get very, very complex. This is the best way I saw of being able to show a visual of a real application with a little bit more complexity. That security, that control, the observability, all baked into this.
Yeah, and I like the way this looks too. On the peripherals, having that egress, that's the one I usually keep my eye on mostly for billing purposes. But getting this full view is great, and of the security as well. It's something that, at least as an application developer, as an application background, we admittedly don't always have the strongest view of how networking capabilities work. So this is a great view into that.
Yeah, and as we start to look at, hey, why would people be interested in doing this? So as you move to more and more microservices, being able to do so at scale, right? If your solution is to throw a load balancer in front of every microservice, like that's going to take some time to set up and some difficulty to manage. So this is an alternative approach to that. That's going to get you like automatic load balancing. I talked about the improved observability as you start having dozens and hundreds of thousands of microservices. Controlling that traffic is going to get you a few things, right? So the ability to do canary deployments, blue-green deployments, and then even like chaos monkey style testing as well. So now you have the knobs and the levers to start in controlling and shifting things around and seeing how your application is going to handle it. It's a great bridge for modernizing applications. So the tools that we'll talk about in a few minutes with Istio and with Console, they allow you to register VMs and like VM services into the service catalog and ServiceMesh as well, so that you can start managing your monoliths alongside your microservices here as well. And as you start stripping out features and services into microservices, like the ServiceMesh will help just manage the traffic between them too. So that's why it's a great bridge for modernizing those applications. And then I mentioned as well how it enforces mutual TLS and starts looking at security on the inside rather than just perimeter security. So there's a number of different tools in the ServiceMesh world. Two main ones that I'm going to call out here are Istio, which is open source. I think it was primarily founded and built by IBM and Google. Probably other contributors along the way too. And so Istio provides a lot of the benefits that we talked about here. And additionally, like it provides like RBAC level access control for namespaces, services, and methods as well. All those great benefits around traffic management. Some of the monitoring side here that you'll get from Istio and other ServiceMesh, like you're now going to get automatic metrics collection for your services as well, requiring like minimal, if any, code changes from your software engineers and for your apps too. And then it provides built-in dashboards from an observability perspective too.
And a lot of Google services like ServiceMesh are either wrappers, or we've talked about this before, almost clones with, they're very compatible with a lot of these open source technologies like Istio. Actually, Istio, I think in the background is powered by Apache, but I'm not going to go into that deep.
And it also integrates really, really nicely with GKE. So following the Google theme, if you're running your workloads on like GKE, Istio is a great solution for you there. It does have some considerations, so it's extremely powerful, but it's also fairly complex. So it can be pretty challenging to set up and be able to manage. I guess hand in hand with the next one, a little bit around it's open source, yay, but also that means like as an enterprise, like you got limited support. There are a couple of third parties who do enterprise support for Istio. I think they've built up a lot of experience around it, so they're now able to support as part of their business, like other companies. But again, it's coming from a third party rather than from the vendor. And then it's built for Kubernetes, so it's primarily designed for running like Kubernetes-based workloads. You can register, as I mentioned, like other services and VMs, but you'll notice as you go through it, like how it's really focused on Kubernetes. The next one, as a kind of a sharp contrast to be focused on Kubernetes, is HashiCorp's Console. And this is designed to be very cross-platform, cloud agnostic, so hybrid cloud, multi-cloud. The idea with Console is you can use it as your service mesh and your network layer, your service or application-based network for your data center workloads and your cloud workloads. Doesn't matter if they're running on VMs or Kubernetes, on-premise, AWS, Google. This is where Console really shines. So again, much like with all service meshes, you're eliminating the need for load balancers. It's great for as you start spinning up more microservices, and it's going to automate that traffic routing between wherever your workloads are running, on-premise or cloud. So considerations with Console versus Istio and Linkerd and others would be like it's a simpler deployment, so it's easy to get off the ground, up and running, and easier to manage. I mentioned the flexibility of truly being platform agnostic, and that's kind of one of the core tenets of Console. And then HashiCorp provides enterprise support as well. So like with all things in this space, like the open source is oftentimes great for getting started, and then once you want to be able to do so at scale or with your production workloads or with a smaller team, whatever it might be, having the peace of mind that comes from enterprise support can often be key. Whether it's from HashiCorp or from partners like Burwood. Shameless plug.
Like many things, some things I want to get my hands dirty on and touch and make sure to control them. Other things I just want to have run for me and not have to worry about. And this is probably near one of those things that I'd rather not have to worry about. And someone's already solved this problem, and I'm going to let them take the reins. And I think that's the advantage to a tool like this.
Cool. So Rich, we 10 minutes left, and we got a couple of things to cover with test modernization and AI ops. Yep, absolutely. And
so first, really quick, we all know there's going to be bugs. Even NASA, if you've heard the story before, has bugs in the software that they've built. So whenever a client or a customer comes to me and like, why is there bugs in my software? I just tell them, look, the smartest people on the planet can't stop bugs in the software. So let's go on to the next slide. There's a lot of different testing methods and approaches that we've all heard of, from just smoke testing, quality and assurance, just to make sure that everything's behaving in a way that's acceptable to users. You have your functional testing, which means it's doing what it's supposed to be doing, and your non-functional testing is what happens when it comes under increased load, or what happens when the server goes down, or what happens when the whole data center goes down. So, having those type of plans is, and being able to test those scenarios out is very important. Let me go on to the next one, Ed. So here's some static testing and analysis tools. Basically, this means they're going to run without having your code to compile. And, there's a lot of cool tools out there that will keep your code base clean and your standards met without even a lead developer in place to have to control those things. You could have gated check-ins before that. And they do provide security analysis. And they're really, again, smart is that if you use it knows, you could set a policy that says don't declare any variables in the middle of your function, or don't have any static strings that aren't declared as a, public stack final or a read-only variable. And, it will say, oh, we detected you did this, you need to throw it up here. So there's, again, SonarQube is one of the great high-level ones that really tracks your entire end-to-end process. But there's a lot of other cool tools out there as well. We go to the next one, Ed. So dynamic testing versus static testing, this is where you are, you need your code compiled. And there's unit testing, integration testing, and system testing, and finally user acceptance testing. So the idea here is that when you're unit testing, you're testing the smallest unit, and everything around it that's both in and out should be controlled. So you'll set up a fake client or a fake repository if you're testing an API service. Your integration test, now you're testing one or more components, or I should say 2 or more components, to make sure that the connection between those still works and that contract is there between both components. And finally, a system test is your full system test. Obviously, you don't want to test in production. It sounds like that's what these guys might be doing. Oh, there's where the slide was. So this is what happens if you test in production, which this guy did. Again, if you've seen the movie, where maybe he should have had a tester take a shot at it first, somebody else there. This is one of my favorite images of automation. Automation to me is the holy grail of getting an application team and having an application developed and run smoothly. You get all of these great things, out of automation. Here's a high-level look at what your DevOps and automated testing process looks like. You again plug in a lot of these automated tools and make sure there's gated checks along the way, to where before it even gets to the code review, the lead developer knows that everything's been taken care of, and he doesn't need to waste his time other than checking the high-level things. And again, you're able to keep track of all this using SonarQube at the highest level. You go on.
And these slides will be available afterwards as well. So if you like this diagram as much as I like it, and want to appreciate the time and effort that Rich put into building it, it'll be available afterwards too. So getting into AI ops and ops automation. So I want to talk about continuous delivery with AI, moving to more advanced event management, and then even doing incident automation as well. So during the last session, somebody asked a question around, have we seen people use CD tools that feature AI capabilities? And a couple of weeks ago, we hadn't. So we did a little bit of digging, spun up some quick proof of concept. And there's some great tools out there, one of which is Harness, where Harness is a fantastic continuous delivery tool, providing a lot of the advanced capability of Spinnaker for doing CD on Kubernetes, but in a very easy to use, kind of enterprise friendly, quick to get up and running with Mana. So you can see how easy the UI is here. One of the things that they do is they'll do, when you do a deployment, you can maybe start with a canary deploy, validate through a number of different event sources, for example, New Relic or AppD. Hey, what impact did this have on the performance of the application? Similarly with logs, what are we seeing any anomalies or issues in the logs, from Splunk or Elastic? And then it will.
No, that's so cool.
I
was just gonna say it's amazing that you found this. This is so. Somebody asked it during our first session, and I'm so happy that you've dug into it since then, because no one would think to use AI and ML in their actual CI/CD process and not, actually part of the process, not outside of it, right?
Right. So you can make an informed decision on when you want to proceed after your canary deployment. You can have that automated. You can have it automatically roll back if there's issues as well. And then there's obviously your regular sort of like approval process in there. Very easy to use UI too. So this is just a very quick sample that I spun up with like a sample app that they had. You can see how it's split between like the pre-deployment steps, canary deploy, your primary and your post-deployment. Getting into advanced event management, this is basically we want to start with, like, I go through 5 steps here. So event ingestion from multiple sources, getting all these different sources into one system, then being able to look at like noise reduction. So how do you start using AI to move away from static thresholds into like dynamic learning thresholds, where you can start identifying patterns and detect anomalies, and start moving into like proactive detection here as well. Then, because you're getting events from different sources, you're able to correlate them. That'll help you determine a root cause. If you start getting like your change data, your topology data married up with your events as well, feeding into your AI system, you can start getting suggestions on root causes here as well. And then my favorite, getting into automation. So this is a simple example of how we integrate Stackdrive with ServiceNow and Ansible, so we can automatically run diagnostic tests and have the results kick back into the ServiceNow ticket for our engineers as well.
I love the use of UML there to normally what's reserved for code sometimes, but it's a great process flow.
So we have thoroughly enjoyed having you on this journey. Rich and I love geeking out on this stuff. Thank you so much for your time over the last 4 sessions and this 2 months and a house move in the process for me as well. So we've enjoyed having you here, and we would love to geek out with you on this afterwards as well. So with that, Colleen's going to bring us home.
Yeah, absolutely. And I just can't repeat enough of what I've said. I've enjoyed, chatting with you so much during these and building out the decks. I don't think I've had so much fun as other people could probably tell building out decks. They really let us off the hook here. And I was like, all right, I'll push that as far as I could go. But again, I'd love to connect with any of you. We both would. And just, again, like Ed said, geeking out, doing architecture assessments, just, hey, solving little problems, whatever you got.
Absolutely. Thank you both so much. So as you can see here, wanted to tie it all up at the end with a bow. For those of you who've been on every session, we've gone through some fun themes, like they said. It's been equally fun for me as a marketing person to go off brand and have some fun with these slides. So I hope you guys enjoyed the entertainment faction as well. So thanks all for joining us. As you can see here, just recapping, we really tried to give you a good picture of how and why to modernize. From the very beginning stages with Google Cloud, understanding its capabilities and why it's such a great platform, all the way through how to onboard, and then starting with application modernization fundamentals and today advanced modernization tactics. So if you've missed any sessions, all of them are on a Burwood Group's YouTube channel, and we're going to create a little channel single link so you can go ahead and view them in one special spot. So everyone on today's session will get a follow-up email that includes the slides from today and then that link to the full channel for all 4 sessions. Taking us to the last slide, like Ed and Rich said, we would love to hear from you if this is an interesting topic for you. Hopefully the education we provided you with kind of sets you forward to go out on your own if you desire and really work and enable yourself to do what you want in your own organization. But as Rich was saying, we would, of course, let's be honest, we'd love to help you if you want some outside opinion or guidance. So whether it's building your app modernization roadmap, or if you're ready to run a proof of concept, modernizing a single app on Google Cloud, whether you're already using Google Cloud today or not, we would love to talk. So please reach out to Ed or Rich specifically. And then lastly, when you close the WebEx window today, you will see a survey automatically pop up We would love your feedback if there are additional topics you want to hear from the Burwood and PrimeTSR teams. We hope to do more educational sessions and series like this in the future, and you all have been so engaging throughout, asking awesome questions and collaborating, and we would love to do more topics that specifically interest you. So please let us know. All right, and with that, thanks everyone. It's been a blast over the last couple months. Reach out if you'd like, and thanks again. Have a wonderful day.